Hi guys, today I have a really cool problem for you. We are going to be graphing piecewise defined functions. But what is a piecewise defined function? A piecewise defined function is pretty much a function that is, you guessed it, defined in pieces or by pieces. So for example, we have f of x equals either it equals the square of x minus 2 plus 1, or it equals x or it equals 3, just depending on the domain. Okay, so this function is defined in pieces. So the first piece is given by f of x equals the square of x minus 2 plus 1. But we're going to take a pause on function notation and we'll just replace it with y. So the first piece is defined by y equals square of x minus 2 increased by 1. But for the domain, if x is less than 2. Now, what if we're looking for input values or x values that are at least 2, you know, or hence the greater than or equal to 2, then that piece is going to be defined by y equals 3. Okay, so the graph of the first piece should be a parabola, so it comes from the square of the basic function y equals x squared, and then, you know, we go 2 right, 1 up, and there you go. But the domain is for x is less than 2. So because 2 is not defined in the first piece, it is very important that we highlight that it's not, so hence the open circle. What if we wanted to graph values that are at least 2, so x equals 2, 3, 4, 5, and all the fractions in between? That's where we look at the second piece. So the graph of y equals 3 is pretty much a horizontal line that, if we could extend it, would go through positive 3 along the y-axis. So we start at 2 and keep going forward. Now the question is this function continuous? Fortunately, it is not. Why is it not continuous? Well, informal definition is this: if I can graph this function without having to lift my pencil, then the graph is continuous. But as you can see, in order for me to go from this bottom point to the top point, I need to stop, lift my pencil. Let's pretend it's a pencil. Okay, I have to stop, lift my pencil so I can continue to graph. So this function, it actually has a point of discontinuity. In this case, we had to take a break at x equals 2. It's in my way. We had to take a break at x equals 2, so we have a point of discontinuity at x equals 2. But that was enough about that. Let's get to the fun problem. It's such a fun problem. You may see it on your first midterm, so don't say I didn't warn you. So it says, sketch a graph of the piecewise defined function. You may use a calculator to support your answer. Then evaluate f of negative 2, f of negative 1, f of 1, and f of 2. So pretty much we want to evaluate the function at those input values. Sometimes I get so excited to graph the piecewise defined function that I forget to answer the third part, you know, evaluating the function. Okay, so this is how it's going to go down. I like to speak to myself a lot on paper. If I don't have a paper trail, I will forget. So let me go ahead, write piece 1. And how is the first piece defined? So we have f of x equals x plus 1. With your permission, we're going to take a small pause on function notation. So we have y equals x plus 1. And then I'll write down the domain if x is less than 0. So if I wanted to pick x values that are under 0, this is my go-to guy. So in this case, the degree is 1. So the biggest exponent on any of the variable terms is 1. So let me go scratch that from the top. Since the degree is 1, then the graph should be a line. I mean, it could be a line pointing up, pointing down. I don't know. I will have to do the math because my mental math is not so good. So we can do a table of values, or you do what you gotta do. But I'm going to show you something neat. Given that we can use our calculator to support our answer, this is what we're going to do. Okay, so let's go ahead, take it out. And then I should have cleared this. I keep forgetting to clear. Ignore that. Okay, so we have y equals x plus 1. We have already established that the graph is a line. The wrong window. Let's come back home. So we'll do zoom 6. Okay, zoom standard. Okay, so we have a line that goes up, and then let's go ahead and do our table of values. So we have x, y, and then I can't use 0, so we'll go ahead use 1. Okay, so we can do second calc value, but let's go ahead go to our table of values instead. Let's see if this is set up neatly, because you know I forget to clear my stuff. So second table, and okay, it's good. So when x equals not 1, my mistake, okay, -1. Okay, so I'm gonna go ahead scroll up. When x equals -1, y equals 0. Oh, do we really need a calculator? No, you can do it in your head. -1 plus 1 is 0. But silly things happen when you're a little sleep deprived. Okay, we have established that this will be the first piece is the graph of a line. And in order for us to do a line, we need 2 points. So let's go ahead locate a second point. So -2. -2 is in the domain, so we can use it. Let me go ahead scroll up, and then that will give us -1. So again, you can do it in your head. -2 plus 1, -1. I know you're a pro. Okay, so let's go ahead graph these. Okay, so we have -1, 0. So let me go ahead and use my red pen. We'll see how this works. So we have -1, 0. So 1 to the left, and then we stay put. And then -2, -1, 2 left, 1 down. And then I'm supposed to connect these, making sure that I don't go where am I past 0. What I'm gonna do right now, let me see if I can convey what I want to say. Technically, I'm not supposed to use 0, okay, because 0 is not part of this domain. But I'm in no mood to pick -0.9999999. I said it wrong. Scratch that. I'm in no mood to pick -0.0000001. Okay, sorry. Things happen. But I want to know how would the graph behave as we come close to 0. So I'm going to pick 0, but I'm going to put a note, open circle, okay, because 0 is not in this domain. We don't need a calculator for that. So if x is 0, again 0 is not part of this piece, but we just want to know where would it be, so that way I have a sense of where to stop. Okay, so we have 0 plus 1 is 1. So we know that when we connect these 2 points, then this piece should stop at 0, 1. So let's go ahead do an open circle at 0, 1, so we stay put and then go up 1 unit. And then we'll take a straight edge to do our points. And the question is, Ms. Torres, do I really need a straight edge? Can I just freehand it? No. Okay. If we're writing together, if your graph is a straight line, I need to see straight lines. That is the only thing that I ask. If it's not a straight line, then yeah, freehand it. You tried your best. Okay. So we have a line that goes up, making sure it doesn't pass 0, 1. Okay, so I try my best. Sometimes I move my straight edge. Look at that. I'm so proud of myself. All right, so 1 piece down, 1 more piece to go. Okay, so piece 2, I lost my writing instrument. Just found it. Okay, small scare. Okay, so piece 2. Piece 2 is defined by f of x equals x minus 1 if x is greater than 0. Again, I'm going to take a pause on the function notation. So piece 2 is defined by y equals x minus 1, and then that's for the domain if x is greater than 0. So strictly greater than 0. 0 is not in either one. Okay, so once again, we have an equation of degree 1, so the graph should be a line. Okay, I know you don't need a calculator, but I'm gonna do it anyways. Okay, actually no, I need you to help me. Okay, so let's go. In order to do the graph of a line, we need 2 points. So let's go ahead pick 2 numbers that are in this domain. So with your permission, we'll pick 1 and 2. How about that? Okay, so if x is 1, 1 minus 1 is 0. Let's go ahead graph this bad boy before we forget. So we go 1 to the right and we stay put. And then when x is 2, 2 minus 1 will give us 1. Again, let's go ahead graph that. 2 right and then 1 up. If you use your imagination, we have another line that's going up. But again, we don't want to start just at this point because we have more numbers in this. We have more part of the graph. You know, we need to come close to 0 without passing it. So I'm going to use the same strategy. When we extend it, I need to know where will we stop at. So I'm going to go ahead pick a 0. You know, that's the end point. But I want to remind myself that 0 is not in this domain either. Okay, so where would it be if it was? So if x is 0, 0 minus 1 is -1. So remember, 0 is not in this piece, it's not in the domain, so we're going to have to put open circle. So that will give us 0, -1. And the reason why we need to highlight is because we need to know where does the graph stop. So let's go ahead and take our straight edge. We're not graphing anything, so a ruler is not a must. You just need anything that has a straight side. I have my plastic bookmarker. Okay, never leave home without it. Okay, fantastic. So we graphed both pieces. We showed how the graph looks as we approaches that endpoint. 0 for the first piece, 0 at the second piece. We're good, but good thing we put an asterisk right there. So we are asked to evaluate f of -2. Let me give you a short version. We are asked to evaluate the function at -2, -1, 1, and 2. Okay, so let's do this. So when the input is -2, I gotta see in what domain does it fall under. Is it gonna be for the first piece or second piece? So this one is gonna be for the first piece because last time I checked, -2 is under 0. So let me speak to myself. This is in piece 1. I don't have time to write those words, so I'm just gonna make up my own abbreviation. Okay, so we have f of -2. Okay, we're using piece 1, so if x is -2, -2 plus 1, I believe is -1. You'd be surprised how often I make arithmetic mistakes. Cool. All right. Sorry about that. When x equals, or when the input equals -1. Sorry about that, guys. So when the input equals -1, -1 is also in the domain of the first piece. So let me just put P1. That's my own understanding that it's in the first piece. Okay, so that will give us f of -1. We'll substitute a -1 for x. -1 plus 1, I believe, is 0. Fantastic. I'm running out of space, so I'm going to start a new column. F of 1. 1 is in the domain of the second piece, so let me just go ahead, my made up abbreviation, piece 2, 1 minus 1 is 0, so we have f of 1 is 0. Cool. F of 2, let's see which domain is it. So 2 is in the domain of the second piece, so when x is 2, 2 less 1 is 1. All right, so we graphed this bad boy. We graphed the piecewise defined function. We evaluated the function at those 4 values, and we're good. And if you want to see something neat, we can actually confirm our results from our graph. So f of -2, when x is -2, what is the value of this function? So we're going to locate -2 on the x-axis, and then we're going to go up or down until we hit our mark. So let me go ahead, zoom in as much as I can. Okay, that's how big is it's gonna get. Cool. So when x is -2, the function should be -1. That's what we got it. When x is -1, the function value should be 0. Cool. When x is 1, where am I? When x is 1, the function value should also be 0. When x is 2, the function value should be 1. How neat is that? Huh, cool. Fantastic. Thanks, guys.